here are two major ingredients needed in preparing some of the indices questions, right? So almost all the indices questions are based on these two ingredients. So what I mean by the ingredients is that they are the laws, right? The rules that you have to obey in solving almost all the indices questions. So let's look at the first ingredient, or the first law. So the first law of indices, that says that that law is assuming. So let me explain that in just a few seconds. So assuming you have let's say you have a car, right? So this is just a car, right? Just a simple car here, with what, the first load, right? So assuming there's a load here, right? So this car carries what, a load. Then we have another car, right? So what I mean by another car is that same car, maybe let's say today you see that car with what, this load, and then tomorrow you see the car with what, another load, right? So the same car, maybe today this is for what, day one, right? Day one, then this is what, day two, right? So day two, on the first day you see the car with this type of load, and then on the next day you see the car with what, this load, the same car. Is that okay? So the operation is just a multiplication by assumption, just for understanding purpose, right? Let's say that the two cars are being multiplied. So what happens is that since these cars are the same, then the law of indices is saying that you should just add their exponents and then repeat the car. Of course, the car is just one person, right? Just one car, right? So what I mean by one person is just the same car that we are talking about. The same car you saw yesterday, the same car you are seeing today. So the first law of indices is, so when I want to bring that into the mathematical term, what it means is that when I have the same number here being raised to a power, right? So let's say a power x here, and then be multiplied by another same 3. Obviously the same cars, right? The same car here, the same car be raised to what, a different what, power. Then all that it means that they say you should just add the exponent, right? This is what we call what, exponent. So we are just adding and then repeating that car, right? So that should be what, s plus 2, right? Since they are multiplying, this is one thing you have to focus. So the first focus, you have to check that is it the same car that what, are carrying the load, as well as are they multiplying. So if this still happens, then just add what, the exponent, right? So just add the exponent. Now in the other way around, if it is what, division, right? You know, they are dividing, then that is just the vice versa, right? They say you should subtract, right? Just subtract the exponent. That is very simple, right? I hope this thing makes some simple sense. This is just for illustration purpose. Is that okay? Now these are the two major tools in indices. So let's see how to use these tools in solving some of the exams questions under indices. So here's the first question. From the question, they say you should solve this equation, right? So this is the equation. They say you should solve that. What do you know? You just know only two laws, right? Two ingredients. So how can we use those ingredients in solving this type of problem here, right? So what do we know? We know that if it's the same car that is carrying the load, right? If it is the same car that is carrying the load, then we can just add the load that they are carrying. Does it make sense? So that is what we know, because there's a multiplication here. So that tells you that you have to make sure that you are having the same car here, right? So how can we get that same car? What I mean by that is you have to make sure that you are having the same number here, right? The same, these two numbers has to be the same since they are multiplying. For that reason, we can add the exponents. Okay, now and then you equate everything to 64. Of course, so you have to make sure that it's the same car that you are having here. For that reason, you can equate whatever they are dealing with, just like a one person doing the thing multiple times, right? So okay, so how do you have to do? You see, this guy is the smallest one, so you have to check whether you can change this guy to suit this number here. So let's say this is the original car, right? So this is the original car. So this is 4 being exponent of 2 minus 4 x. So how can I get 4 out of this guy here, right? Can I get 4 here, as well as can I get another 4 here? So if that happens, then I can just add the what it's been carrying here, since it is multiplying, then I'll create that to the exponent. So that, of course, here I can get 16 exponent 2. That will give me 4. I see that I'm having the 4 here, that same car here, right? can see that same car here, because 4 exponent of 2 will give me what? 16. Is that okay? Just look at what I decided to put this thing in bracket for you to see that we are not doing anything to the load being carried here. Is that okay? Okay, that is equal to 64. Then let's carry on, because you see this is being raised to the power of 2. There's no law that says that anything raised to the power 2, then you should add the exponent that is happening. So here we can expand the bracket, right? Can you see that the 2 here? So let's add this load to that load by what? Multiplying. So we are not doing anything to the first part, right? We are not doing anything to this guy here. So what we are going to do here is that we are going to use the 2 here to multiply whatever is here, right, to make it just one load. So 2 multiplied by x, that will be what? 2x, and then you see that that same 2 is being multiplied by the 1, so that will be what? Equal to 2. And then look at the 64. What happens to the 64? Because we want to make sure that we are seeing the same car throughout, right? So with that reason, with that at the back of your mind, you can be guaranteed that when I'm able to get those cars, then I can just add their loads and then equate to whatever I see here, right? So 64 here can be break down to that same car here, which is 4, and then 4 exponent of 3 will give you more 64. This thing, if you are not good in the numbers aspect, you can use the calculator to check that, right? So what matters here is that you have to make sure that you are seeing the same car throughout. Is that okay? Now we go to the point whereby we can apply that our law, right? That law or the ingredient that says that if you can see the same car here and then they are multiplying, we can add their load, right? So this is the first load here, this is the second load, and all being equal to this guy. Is that okay? So what happens? So we are just going to add the load, right? Because it's the same car being carrying the load from today and tomorrow. Okay, so this is the load. So this is the car here, the car being carried by this load. That is what 2 minus x for the first day, and then the second day plus what 2x or plus 2. That should be equal to what? 4 exponents of 3. Is that okay? Okay, fine. You see this equal sign here, because there is the same car here, that is 4. So what happened? I'll just equate whatever is here to this guy because of the equal sign. They say whatever is here must be equal to whatever is here, and then we cannot ignore the car. And then let's check the goods that they brought. So the goods here are the exponent. Is that okay? The goods are the exponents here. So what happens? So this guy here being added, so let's just add that and then equate that to the 3 here. So the car is gone already. Okay, so that's very simple. Here we know how to add and subtract all our numbers, or maybe algebraic expressions. So what I have, just have to group and light them. I can see the 2 here, the same 2 here, right? So let's add those 2. That gives me 4, and then minus x plus 2x, right? So minus x plus 2x, that should give us x. Because you see, if you are not okay with the algebraic expression, all that matters here, you have to check that the letters are the same. If the letters are the same, we can do the operation, right? If they are not the same, there's no way we can combine them. In this case, it is just x, it is x. So that is just what minus 1 plus 2, right? Minus 1 plus 2, that should be equal to 1, right? So that is how I got the x here. So when you solve for x here, this 4 will go away, so that should be what x is equal to minus 1. Is that okay? So this is how simple they trick the questions for you to have some little time in solving that. You just need to understand what the method and how it works. So let's have a look at the second question here. From the question, you are given 2 different type of equations. They say you should join them, forming 2 different equations in terms of m and n, and then you find the values of m. So this is the first question, right? This is the first equation here. So that's about 3 exponent m multiplied by 3 exponent n, all is equal to 243, right? And then what do you know? We know that if you can see the same car being carrying the load here, and they are multiplying, so it is the symbol, right? You have to make sure that whatever is here, you can see that same number here and it's being multiplied. The law says you should just add their exponents, so we are okay with this part. What about this guy, right? You just have to make sure that this guy also suits that same car. Is that okay? So can you get 3 exponents something out of this number? So that is our aim. So that is something that we know. Why are we doing that? We know that once we get that, we can just add this thing and equate it to whatever is here. So here we are not doing anything to the left hand side here, and then here is 3 exponent 5. So 3 exponent 5 will give me this. Is that okay? The reason why we go for the 3 is that we want to see the same car, we want to see the same numbers across, right? Okay, now what happened? We know that if they are multiplied, we can just add the exponent, right? You can just add it. What is the exponent? So that is the n plus n is equal to 5, the exponent here. So the car goes away. Is that okay? So this guy will just goes away, right? So that is the car that brought the goods. So we are okay. So we are grateful for your service. So let's move on. So what are the loads? So let's focus on the load now. Now that we have n plus n is equal to 5. So let's say that is there for the first part. What about the second one? So here comes the second ingredient here, right? Here comes the second ingredient. Let's see how to apply that. So as I said at the beginning of the video, so if you can see the same car and then they are being divided, right? There's a division sign separating the two expressions here. That we can see that you subtract this one from or you subtract this from that, right? So that should be n minus 2n. What is the reason? The reason is that it's the same car, right? And it's being divided. So 3 the same numbers here, and then they are dividing. What I have to do is just subtract them. So that is our n minus 2n, right? Okay, what is happening on the right hand side? You can see that this is 9. So you just have to check whether you can see that same number out of the number being given here. So here is 9. Of course, I can get 3 there. So that should be 3 exponent 2 will give me 9. Is that okay? So up to this point, I think we have already 50% solved our problem here, right? So what I have to do here is just subtract the exponents. You know the point at which you can subtract. This is when we can subtract, right? Okay, so that should be n minus 2, and that should be equal to 2. Is that okay? So the car goes away. Okay, so perfect. Now that we got the two equations, so let's name them one by one. So this is the second equation, and then this is the first equation. There are two different equations here, right? Here comes another term by name of simultaneous, right? So you just have to solve the two equations simultaneously. So how do you solve these two equations? The way of solving these two equations is by simultaneous equations. What I mean by simultaneous, meaning that we are going to solve them simultaneously. They should all happen at the same time. So one method is by elimination, right? Elimination, and then by substitution. Which one you are comfortable, you may go for, right? So you are not restricted. You can decide to go for any of the two. So here I decided to go for elimination. If you don't know how to solve that simultaneous, just comment down below, right? Just comment, then we are ready to help you out. So by elimination, I decided to subtract the 2 from 1. So that is 1 minus 2. Okay, so 1 minus 2, that should be what? So this is the first equation minus the second equation. So how do you subtract? This minus that minus that, and that minus that. So 5 minus 2 will give me 3, and then this minus this will give me what? Positive 3. And so look at something. This is just 1 here, right? So 1 minus, look at it, here's a minus here, so minus 2. Okay, that should be equal to 3. Okay, so that was how I got it 3, and so this guy goes away, right? So that is one trick about elimination. When you are eliminating, make sure that, as the name suggests, you are eliminating. So one element should be omitted, right? Should vanish. So you can see that after subtracting, the n mod goes away. So I'm left with 3n is equal to 3. So when you divide both sides by 3, that should be n is equal to 1. So once I get one element, then I can get a second one, right? So how do you get a second one? You just pick that and plug that into any of the two equations, right? Any of the two equations. So I decided to go for the first one. That is what I see to be easy for me. So I'm just replacing my n here by 1 to solve for the m. So this is what I'm having here. So substitute n is equal to 1 into equation 1. You have to write that. Okay, so then you have n plus 1. We are just replacing this n by 1 from your equation 1. So that should be n plus 1 is equal to 5. You solve this, you have your m to be equal to 4. So this is how simple you have been using the tools in solving most of the problems under indices. So here's the third question. So as at now we just know only 2 ingredients, right? We are just using 2 tools in solving this type of problem. So how can we use that to solve this type of problem here? So this is an equation sign. So from the previous 2 questions you can see that all that we are doing is that if this guy and then whatever is here is the same, then we can just equate the exponent, right? So now our focus here, you have to make sure that this guy must be raised to certain power, right? Certain power. So the power here has to be what? 5. Look, just look at something. When I have 2 exponent x, right, is equal to, let's say 4 here. How do you solve this problem? This is the indices. Is that okay? You just have to make sure that this guy here and this guy are the same. Then if they are the same, then we can just equate. Is that okay? Meaning that it's the same curve that brought those 2 goals. Is that okay? So here is what 2 exponent n. Then we can do something here, right? This guy here can give me 2 exponent 2. It's the same thing. So 2 exponent 2 give me 4, and the 4 here. Have you seen that they are the same? We are just rewriting this type of a number. So what happens if this happens? Then we can say that this guy is the same guy, right? So therefore we can equate the exponent. So that will be what x is equal to 2, right? Now look, have you seen what happens here? So what will be the case? In this case, all I have to do is that you have to make sure that this number is being raised to what certain power. So under what circumstance can we equate that to this point? This guy and this guy has to be the same. So we cannot say that this guy want to change the whole number to be x. No, you can't do that. So what I have to do is I have to make sure that the exponents are the same. Is that okay? Why are they the same? If they are the same, meaning that this guy here, whatever I'll get here must be the x. Is that okay? So whatever I'll get here must be my x. So we just need the smallest one, of course. That should be 4 exponent 5 will give me that, right? If you can have a different number here, so let's just comment down below. Let's see if you have a different number that raised to certain power will give you what 1024. Is that okay? Just 1024. That should be very simple to solve. So this is how you use these strong 2 tools in indices in solving some of these exams question. If you enjoyed the video, you may consider subscribing to our YouTube channel for more content like this. Thank you for watching this.